So here is experiment with Asud machine. In this experiment, we are trying to estimate the acceleration of the machine as a function of extra mass, which is um, uh, placed on one of the cylinders. So extra masses in our experiment are always the same. It is they are defined by the metal rings we have for these experiments. So they are given in this column. The distance s traveled by the cylinder differs from one experiment to another, but in one experiment it usually remains the same. So all the measurement of time is done at the same distance traveled s. And for each distance, the time should be measured 3 times because it is not very precise procedure. There are many factors which affects this time. That's why we should measure it not once but several times. And then we should find the best approximation to the real result, and this best approximation is average value. We can find it with a pocket calculator by summing these three values, first plus second plus third, then obtain result, and the result is to be divided by 3, the number of experiments. But in this Microsoft Excel program, we can find it quicker. For this reason, we need to type equality sign. Then we should choose a function. We can choose the function from this menu. If I press this button, insert function, there is a long menu. And by default, we have here the list of recently used functions, but in your case, necessary functions probably will not used. I change it, and we need the function which is average. There are several functions starting with average, and the simplest one is just average. I double click on it, then I should select values for this, and then I press OK. So this is my average value for these three values, and I don't need to repeat this procedure 5 times, because if I put my pointer into the bottom right corner of the cell, then the pointer becomes a black cross, and I can press left button of mouse and pull this cross down. So the cells are filled automatically with the same formula which was used here. And now I have the same formula applied 5 times to 5 lines. So I have time for each value of mass, and now I can calculate acceleration. Acceleration can be found by the equation from the tutorial. I don't remember its number. Probably it is number is not important. The equation is A equals 2s divided by t squared. So let me type it first here. So 2s divided by t. So this is the equation. But in my case, I should replace s and t with the values from cells. So s will be replaced by the value from this cell, and t is to be replaced by the value from this average value from this cell. So we can type it manually, we can obtain it by mouse. If I click at some cell, its number appears in the formula. Now I press enter, and I have this formula calculated in this cell. Again, I don't need to copy it 5 times. I can just pull it down, and I have 5 values of acceleration here. Now we have completed the first table, and in the second table we are determining coefficients of linear dependence of acceleration A small on mass of extra load M small. And to get this coefficient of linear dependence, we could do the following. We can create some chart or graph of the dependence. For this reason, we need to select this column and that column. When I have selected first one, I press Ctrl button and select the second one. Now there is a menu Insert, and here is a panel of many types of charts. The type we need is scatter XY chart. So I take this one, and I should take the first one with points on this. So these are dots, and you see the first title cell was used as a title of the curve. So A meters per S2. S2 means S2 power 2. Well, we can see the line here, but it doesn't look like a straight line. And from the theory, we know that the line should be straight, and we can get a straight line which is closest to our experimental point. For this reason, I point to one of the data point and press right, and I click right button of my mouse. There is a context menu, and in this menu there is a line Add Trend Line. I press it. So here are some parameters of the trend line. The type of trend line is linear, and I'd like to see the equation on chart. That's why I press I check this checkbox. So this equation, I can move it here. This equation describes the straight line, and we can see that coefficient near x is our value of A capital calculated by computer. So it is 44.96, and B is the free term. So the second term is B, which equals to minus 0.0134. These are values of A and B calculated by computer. You should calculate the same values from equation with the data given in your file, and some data is given in the file or with description of experiment, and you should compare those A and this A, and maybe make a decision if they coincide or not. How do you think? Is it good agreement or not? And if it is not good agreement, why we have not completely agreement? So I hope you will be able to do this, to do it without my help. If you have a trouble at this stage, if you don't understand why, example, they are different and you don't understand why they are different, then just fill the table. If you have filled the table, you don't need to do anything. If you understand why the results are different, for example, or if you see that they are equal, you can write some. I think this is because of some reason. Well, this is experiment 1.1. Now let us discuss experiment 1.4 because it contains some special thing. It contains calculation of error. First, let me explain what is the experiment about. So this is an experiment on determination of standard gravity G, and in this experiment we are using a mathematical pendulum. The standard gravity can be found if we know the length of the pendulum and we know the period of its oscillation. The length is changed from one measurement to another, and period t is found by measuring time of many oscillations, because if we measure time of one oscillation, then our relative error will be very big, and we will get always different results for G because of our uncertain determination of beginning of the period and end of the period. To decrease this error, we can use measurement of time for many oscillations. For example, in this table, the number of oscillation is equal to 60. And this t small is time of 60 oscillations. First, we need to find the period of oscillation, which means time of one oscillation. So it equals to t equal to t capital equals to t small divided by n. So here was the formula. And now I replace this formula with formula suitable for Excel calculation. So t divided by n. It means E3 divided by C3. Again, I put my cross to the right bottom corner and pull it down. So I have the same formula applied to 5 values. Now I need to calculate G. G equals to L multiplied on 2 pi divided by T. And the value in brackets, 2 pi divided by t, is to be squared. So the formula looks like this. And I can replace L with its value in some cell, for example here. Then I can use a function pi for pi. Every function is used with brackets. And instead of t, I will type F3. Well, now you can see that the value is 9.804, so quite good, but we could get, for example, at first experiment 995, as we have at the second one. That's why to decrease accidental error, it's better to use the average value, to measure the same thing many times and then use its average value. Example, here I will put average, and now I'll take it from the list of recent functions, average. I need to select cells. So this gives me the value of average G, and now I have the value with 4 digits after dot. I don't know how many digits I will need. The number of digits usually does not exceed 3 or 4, because most of measurements are not so precise that we have more than 3 significant digits. So anyway, during intermediate calculation, it's better to keep longer numbers, to keep more digits than 3. I think 4 significant digits is enough. But its final result, the number of significant digits, is determined by the error we obtained. And here we are going to calculate error using Microsoft Excel's function. First, we need to calculate standard deviation. It is denoted as SG here. For standard deviation, there is a function stdev. So I can find it in a long list of function. stdev, which is at the bottom somewhere. SSS. stdev. You can see there are several variants of this function: stdev, stdevp, stdevs. We should use the simplest one. I double click on it, then I should select the values, select 5 cells, and I press OK. So this is our standard deviation, and to get error we need to divide it by the square root of number of experiments. Square root can be also found in this list of function, or I can type its name, the name of function, which is sqrt. Number is 5. So this is our error, and we can see that the first non-zero digit is on the second decimal place after dot. The error at the final result is rounded to 1 significant digit. Significant digits are those which are all the digits of the number starting from the first non-zero. For example, in this cell we have 3 significant digits, 3, 8, 7, and we should round this value to 1 significant digit only. It means we should round it to 2 significant digits after to 2 digits after dot. I can do it by using format, and by default when we call this submenu with format cells, we at submenu number by default have here 2 decimal places. And when we found our error, we can represent average value with the same precision as the number of digits of error. So in our case it means 2 decimal places after dot. So I will decrease the number of digits, and we have now 9.86 And the final results can be represented in the form G equals to 9.86 plus minus 0.04. Well, so this is how we can calculate standard deviation using Microsoft Excel. The same things can be done in other programs, for example, LibreOffice Calc. So this program allows to do all the same, but it has a slightly different interface, but in most cases the difference is only the appearance of icons. So the pictures are different, but the functions are the same. Well, I think I can stop now screen demonstration.